and welcome back to my channel. So in this video we are going to talk about the differentiation of inverse trigonometric functions. Now before we begin, let's talk about what are inverse trigonometric functions. Now usually we used to write like sine y equals x. So y was in radians and or any angle, and x we used to get in length. Now we know that sine equals perpendicular by hypotenuse. So we have, this is the perpendicular, this is the hypotenuse, and this is the base. So let's say y is the angle and x is equal to p by h. This is sine. This is the ratio. So when we used to input y angle, we used to get x. So therefore we used to write sine y equals x. Now in inverse trigonometric functions, we can write it as y equals sine inverse x. Now it means that when I input any ratio x, I get the angle y. So it's the opposite of the normal trigonometric functions we are accustomed to. So this is what is inverse trigonometric function. We get the angle after inputting the length. So let's try to solve a question based on this. So we have a question, sine we have a question y equals sine inverse x. Now we need to find the differentiation or derivative of y. So we know that we can rewrite this equation as sine y equals x, right? So let's differentiate it. We get cos y, differentiating throughout cos y times dy by dx equals 1. The differentiation of x is 1. So therefore we can write dy by dx as 1 by cos y, right? And in place of y, since y equals sine inverse x, now here we can see that we still have y in the derivative. So what if we need to let's try to make this all in terms of x. Can we do that? Let's see. So in terms of y, I can write sine inverse x, right? So we get dy by dx equals 1 by cos sine inverse x, right? So we know the trigonometric identity that sine square y plus cos square y equals 1, right? That means cos square y equals 1 minus sine y square, right? Also sine of sine inverse x will be equal to x. Now how is that possible? So sine inverse x, as I showed you before, sine inverse x is equal to y, right? From here we got sine inverse x equals y. So substituting y here, and then we get sine y equals x. So therefore this x I can simply substitute in place of sine y. So therefore cos square y equals 1 minus x square, right? So therefore I can rewrite the derivative as dy by dx equals 1 by cos, we had sine inverse of x, and from here we are getting cos y as under root of 1 minus x square. So therefore I can substitute this, since this is y, so we are getting cos y, and I can simply substitute this one in place of cos y. So therefore the derivative will be 1 minus under root of 1 minus x square. So this will always be the derivative of sine inverse x. So whenever you have to find the derivative of sine inverse x, you can directly write it as 1 by under root of 1 minus x square. So let's move on to another problem. So we have to find the derivative of a function, let's say y equals tan inverse x. So we can rewrite this equation as tan y equals x, right? So let's differentiate it throughout. We are getting secant square y times dy by dx equals 1, so which implies dy by dx equals 1 by secant square y. Now from trigonometric identity we know that secant square y equals 1 plus tan square y. So we can substitute this in place of secant square y. So we get the derivative as dy by dx as 1 by 1 plus tan square y, right? And also tan of tan inverse x is equal to x, because tan inverse x is y and tan y is x. So therefore we can simply substitute in place of tan y square. So we can write this equation as, the derivative as 1 plus x square. So this is true for the derivative of tan inverse x. So if we have to find the derivative of tan inverse x, it will always be 1 by 1 plus x square. So this concludes this video, and I will also share the playlist link in the description. Please go through it, and thank you for watching.